Section 1.8 is subsets of real numbers. Now these are pretty basic, and this is a pretty short section, but you have different types of numbers, and it kind of gives you all these definitions. But once again, I'm not big into definitions, so we're just going to cover our 5 main groups. The first one is counting numbers. And for these counting numbers, they start with 1, and it's just like you would count with your fingers, 1, 2, 3. So it's just 1, 2, 3, and it goes on to infinity. The next one are called whole numbers. Only difference between count numbers and whole numbers is whole numbers actually have a 0. They start at 0 and they go to 1, 2, 3, and they go on infinitely. Now there was at one time in math then 0 did not exist, but that was a long, long time ago. Number 3 are integers. Integers are basically your whole numbers, but they can have a negative or a positive sign. So generally they will go all the way to negative infinity. And it's just all your negative numbers to include 0 and all of your positive numbers. But what it does not have are fractions that cannot be reduced. So number 4 is called rational numbers. Rational numbers are basically fractions, in which a is over b, and also in which b does not equal 0. Now we know b doesn't equal 0 because in our class that is considered undefined, and I told you that we won't have any that are undefined. So an example of a rational number would be 4 over 2. 4 can be divided by 2, and that would give you a 2. The last group that we have are what's called irrational numbers. We don't do a lot with irrational numbers in here, but we will use those occasionally. Examples of those are pi. Another example would be the square root of 2. Another example would be the square root of 3. And then there's some other ones, but these are the main ones that you see. Basically, pi represents the distance all the way around a circle. And that formula is 3.14, and then it goes on infinitely. So there's no end to these numbers. So in other words, if I take 1/3, remember that's the same thing as 1 divided by 3. 3 won't go into 1, so I put my decimal point here, and then I can fill in with as many zeros if I want. 3 will go into 10 3 times, and then it just keeps repeating. 3 will go into 10 3 times. So basically, once you see a repetition, you can put a line over here, and that tells you it goes on forever. This is an example, though, of a rational number because there is a pattern. On these numbers, there is not a significant pattern. The other thing that we're going to cover in section 1.8 are prime numbers, and then, of course, factoring. So basically what prime numbers are numbers that are only divisible by itself in 1. So we're going to take a look at a prime numbers. The reason this is important is because in this class, the only prime numbers that I want you to be concerned with really are 2, 3, and 5. If your fraction cannot be broken down, both numerator and denominator, by a 2, a 3, or a 5, I don't want you to break it down. That's starting from chapter 1 all the way to chapter 4. When you get to your other classes, they may have you break them down by 7s and things like that, but for this class, we're not going to be concerned with that. So basically what we use our prime numbers for, and it's basically, and they go on infinitely, there's no set pattern for them. 11 is a prime number, 17 is a prime number, 19. So no number will be divisible into 9 evenly except for 19 in itself, or 17 or 11. So when we factor a number, and that's really what we're using prime numbers for, or to factor. If I factor 12, basically what I'm trying to do is how many times or how far can I break 12 down? So remember, these are our 3 numbers that we're going to be concerned with in this class, 2, 3s, and 5s. Always start with 2 because it's easiest. 12 is an even number, so I know 12 can be divided by 2. So if I'm going to factor 12, this is the way I'm going to factor it. I'm going to say, there's my 2. Every time I use one of these, I circle it because I know it's been used. 2 will go into 12 6 times. Then I keep repeating it. Will 2 go into 6? Sure. It's another even number, so that can be divisible by 2. 2 will go into 6 3 times. Well, 3 is one of my other prime numbers, so I'm going to leave it just like that. So 2 will factor down into 2, 2, and 3. Also acceptable, 2 to the second power, and 3. Either one of these answers is correct. Now, when we start factoring down our fractions, and I'll give you an example, if I have 7 over 14, well, automatically you can see that that's 1/2, but once again, let's look at this carefully. 2, 3, and 5 won't divide into 7 evenly. So therefore, I don't need you to break this fraction down. That's as far as I need you to go with that fraction. However, if it was 5 over 10, let's go through our numbers again. 2 won't divide into 5 evenly, nor will 3. However, 5 will divide into 5, and it will also divide into 10. So I know I can reduce both of these and divide them both by 5. 5 divided by 5 is 1. 10 divided by 5 is 1/2. And that's how I can reduce this one. Now, the way if you tell if numbers are divisible by 2, obviously they're even numbers. The way you tell if a number is divisible by 3 is if when you add them up, that number is divided by 3. So for an example, 126. Well, off the top of your head, that would be pretty hard, and then you'd have to start doing some math. But just to quickly check, let's add all these numbers up. 1 plus 2 is 3. 3 plus 6 is 9. 9 is divisible by 3, so therefore this number could be reduced by 3. Same thing, there's a pattern for 5. Any number that ends in 5 or 0 is divisible by 5. What that means is 5 can be broken down by 5, so can 10, so can 15, 20, and then the list just keeps on going on. So if a number ends in 5 and 0, it's divisible by 5. Simple as that. Now, we're going to use a bigger number because you're going to see one similar to this on your test. If I break down, let's say the number 200, which is a fairly large number, I can go ahead and tell you that your number won't be this hard on your test. However, if I break this number down, I'm still going to go with my 2, 3, and 5. Start out with 2. 200, I know that's divisible by 2 because it's got the 2 in it. So once again, I go 2, circle it, and that leaves me with 100. Once again, keep going. Will 2 go into 100? Sure. I can bust 100 in half, and that gives me 50. Once again, can I bust 50 in half? Sure. 50 will go into half, and I'll have 25 left over. So at this point, 2 won't go into 25 because the number has to end in an even number. 5 is not an even number. 3 won't divide into it because 2 plus 5 is 7, and 7 is not divisible by 3. But the number ends in 5, so I know it's divisible by 5. So therefore, 5 will go into that 5 times. So if I'm writing out all the factors of this, will be 2, 2, 2, 5, and 5. Also acceptable is 2 to the third power and 5 to the second power. And all I'm doing is counting how many times I have them. I have 3 2s, 1, 2, 3, and then I will put it here. I have 5, I have 2 of those, and I put those there.